Okay, it looks like the joins are slowing down, so I'll kind of introduce. This is the Privacypass BOF at IETF 107, one of the virtual BOFs we are having this week. There's a couple things to go over here. One is obviously this session is being recorded. Also, please make sure your video is off to kind of conserve bandwidth. You should mute your microphone unless you're speaking to prevent background noise. For queue management, we're going to use the WebEx chat window. You can use +Q to add yourself to the chat queue, to the microphone queue, and -Q to remove yourself from the queue. So that should be primarily what we're using the chat window for in WebEx. Other kind of conversations should be used in the Jabber room. We may also use the chat maybe for a couple other purposes, but chairs will let you know when it's appropriate to use the chat outside of the +Q, -Q. As I mentioned before, the virtual blue sheets are in the Etherpad, also where the notes are being taken. So you just may need to scroll down or up to find the section where you can log your name in. And finally, we do have a Jabber room. Please join. I think we have a couple folks monitoring that room. So to get started, your chairs today are, I'm Joe Salloway, and we also have Ben Schwartz. I don't know, Ben, if you want to say hi.
Hi, this is Ben. I'll be managing the microphone queue in the chat. So please enter the queue with +Q and then wait for me to call your name before speaking. When you speak, please reiterate your name just in case the note takers missed it the first time.
Okay. So you're probably all familiar with NoteWell, but we'll put this up anyway to remind folks for a minute or so. So please make sure all of the rules about participation are followed. Okay, so here we are. We're going to start out with, we've gone through the administrivia. We'll start out with a description of kind of the problem statement and use cases from Alex Davidson of what Privacypass is, to give everybody an idea. After that, we will want to get a sense of the call if people understand what this is all about. And then we can kind of go on and see what the status of implementations and the status of the drafts are, and Stephen Valdez will present on that. So there'll be time after each presentation to kind of ask clarifying questions to understand more. And then finally, we'll continue on and look at a possible charter. So are there any questions or comments at this point? Not, we'll just jump in. I'll display the slides, Alex, and you can unmute yourself and talk.
Hi, this is Alex. You can hear me okay?
Hold on. This is not the ideal. There we go. Is that better?
Yeah, that works. Can you hear me okay?
Yes.
Okay, cool. So yeah, I'm Alex. I'm a cryptography researcher at Cloudflare. So as Joe mentioned, I'm just going to be walking through some of the problem that we're looking to solve with Privacypass and some of the applications and use cases that currently exist. So next slide, please. Cool. So if you don't know, Privacypass is a protocol intended for the internet setting and specifically to provide a privacy-preserving protocol for providing proofs of trust attestation. And by privacy preserving here, we intend to preserve the privacy of clients who are providing these proofs. So this protocol was first announced in conjunction with the CDN Cloudflare in November 2017. There's a browser extension which you can use for Google Chrome and Firefox, which is quite widely used. But more recently, we've also seen usage in development by other organizations, such as the Chromium and Brave browsers. Next slide, please. So the problem that we're looking to solve with Privacypass is quite a common one. So we have a client and a server, and the client makes a request to the server, and the server has to decide whether to accept that request and process it or not. So this request, we're imagining something to be like, give me access to this resource, or please register this action. And the server will want to know want to have some indication of whether the client is honest or not before it accepts that request. Next slide, please. So to do this, typically what the server would do is issue some sort of challenge to the client. The client will have to solve this challenge before its request is processed. So in the internet setting, this can be something like a Turing test, and essentially what the server is trying to do here is to determine whether the client is human or not, due to the fact that humans are more likely to be honest when they're accessing websites. And once the client has provided a solution to this challenge, the server will accept the request and process it. And here we can think of the server either as just a standard server providing resources, or a server as some sort of gateway that provides access to a number of disparate services that the client can access. So next slide, please. So the problem here is when it comes to propagating that trust. So in the situation previously, the client would have to solve a challenge every time it needs to prove to the server that it's honest. But something that would be really valuable is for the client to be able to propagate that trust to future requests, so that it doesn't have to keep solving these challenges. So what this would look like is the server provides some sort of trust attestation token, and the client would use this token in future requests when interacting with that server, so that the server could accept the request without having to process another challenge from the client. So next slide, please. So this all seems well and good, but there were some major concerns with this model. So if we think of a trust attestation as some sort of cookie, which is usually the way things are done, there's firstly very limited functionality that we can get in the internet setting. So if the server is some sort of gateway and the client is accessing resources on different origins, then this cookie is not going to work because the requests will be cross-origin requests. And equally, if the trust attestation token is something more powerful than a cookie, then this could lead to the server being able to map the client's browsing patterns and subsequently link sessions together, especially if the services that the server is serving are disparate and don't know anything about each other. So this is going to substantially harm the client's privacy when browsing. So with a lack of alternatives, the next best thing is just the client solving a challenge on each request. But the problem is here is these challenges can be quite expensive, and they can also be harmful to accessibility for clients. And in some situations, they can also be infeasible. If the client is, say, trying to provide some proof of ownership of an attribute, but it doesn't want to reveal what that attribute exactly is. So we need a different solution. So next slide, please. So this is where Privacypass comes in. So Privacypass specifically is a protocol for producing unforgeable tokens that allow clients to attest to the ownership of some attribute they owns. And the key property of the Privacypass protocol is that the tokens that are redeemed are unlinkable from those that were originally issued. So in other words, the tokens, when they're redeemed with the server, do not reveal how or when they were created, even though the server themselves issued them. So next slide, please. So how does this fit into the workflow that I brought up earlier? So we have the challenge solution that the client provided previously, but it also provides an extra message, which is the request tokens. So this requests some Privacypass tokens from the Privacypass server. And then when the server decides to accept the challenge solution, it also issues some tokens to the client. And this is known as the token issuance phase. And next slide, please. So in a future request, the server may issue a challenge, or the client may just send a redeem token message itself. And this redeem token message entitles the client to bypass whatever challenge the server wants to provide to the client. So the key thing here is that the client no longer has to provide a solution to the challenge. And these redemption tokens, as I mentioned before, are unlinkable by design. So the client can use these across origins, and the server, and it does not reveal to the server when they were issued, and the client doesn't have to process these extra challenges. So next slide, please. So how does it work? So the underlying mechanism for the Privacypass protocol is this cryptographic protocol for computing what is known as a verifiable oblivious pseudo-random function. I'm not going to go into the exact details of what one of these constructions is, but there is a draft specification that's currently being worked on by the CFRG, so you can read that. And in the protocol document for Privacypass, which Stephen will talk about in his session just after this one, we implement the Privacypass API using this functionality. Next slide, please. In terms of the additional costs, so we're just talking about the additional cryptographic data we have to send in order to instantiate the Privacypass protocol. So for the issuance phase, we have the request tokens and issue tokens messages. And these messages are proportional to the number of tokens that are being issued to the client, multiplied by essentially the size of the cipher suite we're using. So here, the 65 bytes corresponds to the largest cipher suites being used in the VOPMF draft, so these messages are going to be less than or equal to 65 bytes per token. In terms of the redemption phase, the redeem token is much smaller as a constant size, essentially corresponding to an authentication tag, which will be around 64 bytes. For the computation, I'm just going to be focusing on the public key cryptography operations because these ones are going to be the most expensive, so these essentially correspond to the same operations in the TLS handshake. So in the issuance phase, we have a slightly more expensive set of computations, so the client and server perform 3 or 4 of these public key operations per token. But in the redemption phase, we have a much less expensive computation, so the client doesn't have to perform any of these, and the server just performs one to validate the token. So next slide, please. So moving on to the applications, as I mentioned before, Privacypass came out in collaboration with the Cloudflare CDN. So the Cloudflare CDN uses Privacypass as an abuse prevention mechanism in order to improve accessibility to clients that interact with Cloudflare's internet captures, which they use to protect their customer websites. So essentially, what happens is when a client interacts with Cloudflare and has to perform a capture, if they have the Privacypass browser extension installed, the Cloudflare CDN will also provide the user with Privacypass tokens. And when a user then navigates to other origins that are behind the Cloudflare CDN, they can provide these tokens, and they don't have to complete the captures. And the unlinkable property means that Cloudflare can't map the user's browsing patterns. And a second use case, which also corresponds to the abuse prevention application, is related more to the online ad platform space. So essentially, the ad space providers can use Privacypass tokens to ensure that ad clicks are being made by non-fraudulent actors. So what this means is ad space providers need to be able to ensure that clicks on specific ads are made by clients that aren't bots, and they can use the Privacypass tokens to propagate trust. And there are 2 applications which highlight this use case. So firstly, the Trust Token API, which again, Stephen will talk about next in his talk, is an API that intends to be used in browsers, and the Chromium browser has registered an intent to implement, and essentially will just provide the ability to use the Privacypass protocol to propagate trust over HTTP. And Facebook have also highlighted a use case which is based on a variant of the Privacypass protocol with slightly different cryptographic implementation, that essentially for the same application. So next slide. And the second application which we've seen quite recently is one based around anonymous currency. So the Brave browser allows Brave clients to use this form of currency known as basic attention tokens, or BATs, to purchase services internally in the browser. And Brave uses a variant of the Privacypass protocol to provide these BATs to clients. So essentially, the clients have to perform some authorized action, such as watching a sanctioned advertisement. And when they do that, they receive Privacypass tokens, and these Privacypass tokens can be cashed in for BATs without being able to link back to the initial authorization. Secondly, we have an application based on providing anonymous receipts for prepaid services. So leased authority, the security consultancy, use Privacypass as a mechanism for providing proof of purchase and for an access control mechanism linked to their private storage API. And this is also an application highlighted by the Open Privacy Group. So next slide, please. So yeah, just to finish up, and just to conclude, so Privacypass is intended for the internet setting, and we think it provides quite unique properties as a trust-based attestation mechanism for propagation of trust on the internet. And we hope to form a working group that will standardize the usage of the protocol and the specific implementation considerations around creating an ecosystem around that includes multiple issuing servers and multiple clients. There were many open questions around this, and again, these will be covered in Stephen's presentation. But yeah, happy to answer any clarifying questions around the problem and use cases. Thank you.
Okay. We now have some questions. Dave Thaler, you're first up.
Hi, this is Dave Thaler. My question is back on slide 8, I think it was, which was about the problems. Actually, maybe the slides around this. This is fine to leave up on the screen. I have 2 questions. One is, do you see the scope of this as, I guess, this presentation, this protocol, this BOF, as being web context specific or more general than just web? That's the first of 2 questions. And my second question is, what do we think the relationship is between this problem, and again, my questions are on the problem space right now, the solution on the problem space. What's the relationship, what do we think the relationship is between this problem and the problem that the RATS working group is trying to solve, given that that one is about attestation too? Now, I will give a partial answer to that myself, which is the RATS group is chartered to do architecture. And so if you look at the diagrams here, they match almost identical to what the RATS group has, but the RATS group is not chartered to do protocol. And so it could be that the relationship is RATS does the architecture and some of the formats, but not the protocol. And maybe that's what you're trying to do here, but I'm not sure if that's consistent with what you think. So again, first question was, is this web only or more than just web? And question number 2 is, what's the relationship to RATS?
Yeah, so I think the scope of this working group is web only, in the sense that I think Privacypass itself as a protocol could be used in different situations, but I think the scope of the proposed working group would just be in the web context. On RATS, that's not something I know so much about, but happy to have more discussion on that. Yeah, I have to admit, I don't actually know too much about that working group.
Okay, thank you. I think it is very closely related, and my comment is just the more closely it is, the more coordination and less duplication there should be. Thank you.
Just to jump in quick as AD, this is Ben Kaduk. My understanding is that RATS is interested in providing sort of verifiable information about the client or the entity itself, and that many of the use cases here for Privacypass are not as much about the entity as opposed to something that is done, roughly like a proof of work.
All I can say is both diagrams match exactly the diagrams that's in the RATS architecture right now. And so, for example, the server is asking the client to attest that the client is a human and not a bot, for example. And so you have a capture or something like that. The thing that comes back is the equivalent to what RATS would call evidence. And then the token that gets issued is equivalent to what RATS calls an attestation result. And the back and forth flows on these slides match exactly what's in the RATS architecture.
Yes, I agree, and it's definitely a question we should look more closely at. I just want to give a little bit of background about why it's not intuitively coming as the same thing. And back to the queue.
Yep, Brendan Moran, you're next in the queue.
I just want to know whether the tokens are transferable, and if they are not, how you prevent them from being transferred, and if they are transferable, what this is for.
So the tokens are transferable, and do you mean what is the protocol for, or like what is the transferability for? I mean, the protocol is a mechanism for propagating trust. So the tokens are used to provide that trust. The fact that they're transferable is related to the fact that they don't provide any metadata on how they were issued or when they were issued.
Sorry, maybe I didn't make myself clear. Are tokens transferable from client to client? Could I copy some tokens and hand them to my friend and let him use them?
So yeah, in the current protocol based on the VOPRF dimension, then yes, they can be transferred client to client.
Okay, then my second question was, what is this protocol for? You said it was about attesting, for example, that someone is human. If I can take a bunch of I'm a human tokens and hand them to a bot, then what does this get you?
So I think this is a good question. I think essentially, like, they're intended as a finite resource. You're not intended to get them on like a huge scale. I think it's a trade-off between wanting to maintain privacy as much as possible. I think looking at the use case where you would potentially link the tokens to some sort of identity is something that we could consider. But again, this is the outline we have so far.
Okay, Martin Thompson.
Yeah, Martin Thompson. So my question has to do with the amount of information that is propagated across the transfer of information. So you talk to an issuer of tokens, and then you talk to another entity, presumably, although your diagrams have often shown the one entity involved. You talk to another entity who redeems the token. How much information traverses this path? And is there any intention to allow the client to add information to this attestation that it generates?
So in the protocol document, we talk more about the different architectures you have for the server. So I guess you're talking about the client would redeem the token with someone who would then forward that on to the server that actually checks that. So in terms of extra information, I think this is something that would be handled in what will become the HTTP API document, I think, and also corresponds to maybe include adding metadata to the exchange. But I think for now the protocol works just with the cryptographic data involved. So I mean, the way I've presented it is you would just transfer this cryptographic data across, and that can be verified on its own without additional data.
Okay. Well, maybe I'll take this up later. I think this is an important question.
Giorgio Nicolas, you're next. I see you. Okay. Then Subodh Iyengar.
Facebook. I just want to add some to the use case that Alex mentioned in the presentation. And I think somebody brought up whether this is for web-only Flash apps. The place where we're applying this to actually at the moment is more on the apps side of things than on the web. And somebody brought up about the fraud use case. We're actually thinking of this as an additional signal to be used when you're doing things like anonymously logging analytics or things like that. So while this will probably not be the only thing that determines whether you're human or not, this is a very high signal way to determine whether you're human or not. So I think it's used in conjunction with other fraud prevention mechanisms, and it's not the only one to replace everything. Thanks.
Daniel Migaud, you're next.
Yeah, so maybe Subodh just answered to that, but it's not clear to me. Is that an issued token, let's say provided by Cloudflare, could be used with Facebook, for example?
So Alex, Davidson speaking. So the current cryptographic implementation just allows symmetric verification, so the issuing server must also be the one that verifies the token.
Okay, thanks.
Mariana Rakova.
Hi, Mariana Rakova. I first wanted to ask a procedural question. If we want to respond to some of the previous comments, is there a more effective way to do it rather than going through the loop? In particular, I had the answer here about the transferability. I guess this model is more for a setting where these tokens are the possession of the client, and it's kind of the responsibility of the client to guard them, because they will be used by the client as this one-time use authentication tokens. So I think this protocol works in this model that if somebody steals the token, then yeah, they can use it, and this is kind of entangled with the anonymity property. Essentially, you can think of this as stealing your credential in any other anonymous authentication scheme. Right? So stealing the token is not so much about transferability, it's about stealing your credential.
Thank you for the comment. Anthony Nadalin.
Tony Nadlin. Question is, who do you see as issuers of these tokens, right? Because that can potentially be a big fraud issue. So do you see this as a registry of token issuers, or how do you select who can actually issue these trust tokens?
Yeah, Alex speaking. That's a good question. So this is going to be covered, but essentially the idea that we have in mind currently is that there'll be some central authority that monitors the issuers that are valid at any one time. So there will be some sort of registry of issuers that can issue these tokens, and they'll have to register in order to be able to do that. And like they have to publish some sort of like public cryptographic data in order to be able to issue tokens successfully. This is something that we cover in the architecture document currently. But yeah, again, Stephen will touch on this in the next talk.
Thanks.
Thanks everybody for your comments. We've drained the queue, so we can move on slightly ahead of schedule to the next set of slides, or the next slide. So Joe, over to you.
Okay, so let's switch gears here. And so Stephen, if you're around, you can unmute.
Yes, Stephen Valdez, Google. I'm going to go over quickly the drafts, key management ideas, and implementations that we have so far, just as a idea of what the current state of the ecosystem is, I guess. Next slide. Next slide. So the first draft we have is the Privacypass protocol draft, which is a lot like the previous presentation. It covers a lot of the cryptographic protocols, how client issuance and redemption steps actually work, and the requirements of the underlying cryptographic protocols. Right now with VLPRF, it's possible that we extend this with other protocols, and there's the extension policy included in this draft to discuss that. And part of the working group would be to tighten up this draft and see what sorts of extensions we would want as part of the core protocol itself. Next draft, or next slide. The second draft that we have is the architecture draft, which goes more into the sorts of requirements on client servers and the considerations we need to worry about. Particularly, it exposes interfaces that can be used by different applications, use cases on top of Privacypass in order to call into the protocol itself. Things like how the issuer would store keys, retrieve keys, and do the actual messages that communicate with the client. A large portion of this draft is also about how key management works, which we'll discuss a few of the options, including what's currently written. The privacy considerations, since while this does limit the amount of information that can be transferred between the issuer from the issuance time to redemption, there is still at least the one bit of information that is leaked between issuance and redemption. And there's concerns about user segregation if you allow a bunch of different keys for one issuer and other forms of tracking and identity leakage. And as we clean up this document, we'll need to discuss more about the privacy trade-offs that are necessary to support having these like key rotations, even though having additional keys might allow you to do additional bits of data leakage. There are also security considerations in a malicious client might ask for 500 Privacypass tokens, and then on a malicious website or malicious endpoint, it would redeem all of them, forcing the client to lose all their tokens immediately. We also discuss extension policies on the wider architecture side of things, how other applications would build on top of this, instead of how in the previous draft, it's mostly about the core protocol itself. Next slide. As an example, one of the drafts we have initially is the HTTP API draft, which talks about how to build on top of the previous architecture draft for a HTTP use case. It currently talks about the wrappings that you would use to send protocol messages over HTTP headers. The sorts of key management requirements that HTTP clients, notably browsers and websites that use these APIs, would have to abide by. And there's a example of a potential extension called delegated redemption, which is a way for, at least in the web ecosystem world, the ability to, given a Privacypass redemption, send it around to other parties without leaking any information. That way, every website isn't talking to the issuer every single time. And the extent of how much we want in this HTTP API doc is also a thing that we need to discuss as a working group, see what is valuable here. There's a interaction between this and W3C in terms of also kind of an HTTP API, the sorts of like JavaScript APIs, fetch APIs you might need to support the use of Privacypass in the web ecosystem. And some of that might need to be discussed here, and other parts may need to be a liaison with the W3C. Next slide.
So before hi, this is Ben Schwartz. Before we go on, I just want to ask if there are any questions about the drafts before we move on to talk specifically about key management. Hearing no plus Qs, we'll move forward to talk about key management options. Thanks, Stephen.
Next slide. So one of the big things that need to be determined for Privacypass is how issuers manage their keys. In an optimal world, an issuer would have a single key that they use to sign every single Privacypass token, and that means that that one key is the one that's always used. Unfortunately, we're not in an ideal world, so we need to support key rotation in case an issuer loses their keys or their keys are compromised. But we need to balance that with the problem that multiple keys being in use can allow for user segregation, or even on Friday, the issuer may sign Privacypass tokens for one bit of information. On Tuesday, they use a different key to sign for a different bit of information. And we also need to somehow have a way that you can audit that a Privacypass issuer hasn't been changing their keys and presenting different keys to different users. Next slide. So there's a couple of options to do key management here. The first one is that clients would just get their keys directly from the issuer. They'd have to get the keys through some sort of anonymous connection so that the issuer is not like determining that you're user A and giving you the key commitments for user A. You'd need some sort of auditor to try keeping track of if an issuer is presenting different viewpoints to different clients, and for the most part, that's only a mitigation. So directly fetching key commitments from an issuer is kind of a messy and not great from a privacy perspective option. Next. The second option is having some sort of trusted proxy that is responsible for doing this fetching of key configurations, and then clients would fetch it from this proxy. You would have to trust this proxy so that they're not presenting different viewpoints of the world. But if you do have some sort of trusted party, be it your UA or a third party like university that is doing all the fetching and then storing of the key commitments locally, you wouldn't have to be worried about the issuer itself presenting different key commitments. Next slide. The third option, and the one we currently have written in the IETF API document, is a commitment registry, some sort of append-only log, where all issuers would append their key commitments to this log, and all clients would be fetching the key commitments, either from this log or from the issuer directly, as long as the issuer presented some sort of inclusion proof. This does require a slightly bigger ecosystem where you have this sort of append-only log, but it does allow for a cryptographically assurance that this key commitment has been reported to this log. Auditors could then keep track of what key commitments have been reported and take note if they're rotating key commitments too frequently. Clients could have policy for the rate of key rotation allowed. And the log itself could just say that if you're receiving a new key commitment every 5 minutes, then that's probably not a valid key rotation policy. We need to figure out what some recommended policies would be for like how often an issuer would be allowed to rotate their keys. Next slide. So throughout all the documents, there's a number of open questions. These are a few of them. There's the issue of malicious clients getting tokens and then spending them multiple times. In the case that an issuer has different endpoints, you need some sort of eventual consistency. Otherwise, a single token can be redeemed 5 times for the 5 different data centers an issuer might be running. Another problem is how a client and the ecosystem as a whole would be detecting malicious servers. Clients would need to have some way to talk with other clients to say that they've seen a different viewpoint of what keys the issuer has presented. This is somewhat solved if you do something like a log approach to key management, but if you do a simpler approach, which is just the issuer gives you keys directly, you need some sort of way to determine that the issuer has been acting poorly. There's the question of key rotation windows, the balance between how often you want to rotate for security versus the privacy implications of rotating your keys too frequently. And then there's the question of if you allow 5 million issuers, then you get 5 million different tokens and each of those represent 1 bit. So there are some privacy considerations for having a massive collection of issuers, but you also want to avoid consolidation and limiting problems with limiting the number of issuers that exist in the ecosystem. There's possible solutions for this where instead of limiting the number of issuers, you might limit the number of redemptions that a particular site or endpoint would do at a time. But these are considerations and open questions we need to go over. Next slide. And then in terms of current implementations and APIs that exist, Cloudflare has their Go JavaScript challenge bypass extension, which was one of the original reasons behind Privacypass. Brave has a Rust JavaScript implementation for their bats that Alex mentioned earlier, and Chrome is beginning to implement a variant of this for HTTP based on the HTTP API in C and JavaScript. Next slide. Or I guess that's like last slide.
Ben Schwartz here. Joe, could you go back to the open questions slide? Thank you. Ben Kaduk, you're up.
Hi, Ben Kaduk here. I just want to clarify for the detection of malicious servers, is that to detect malicious token issuers or token consumers?
This would be mostly for token issuers. If a token issuer and a token redeemer were 2 different parties, you'd also want to detect that, though I think the issuance is the more interesting problem here, since at issuance time is when the issuer has information about the user.
Right, thanks.
Subodh Iyengar, you're up.
Subodh Iyengar. For the double spending system, do all application profiles need perfect double spending kind of protection, or it seems like we have a variety of different applications, and as we kind of standardize this thing, we'll have more and more new applications, and like it doesn't seem like every single application might need a double spending, kind of strict double spending kind of requirement. Do you see that Privacypass is actually going to be relaxed at depending on application profile, or we're going to put double spending as a hard requirement?
I think there's a lot of use cases that won't need this double spending requirement. I think it would be useful to detail like how you would maintain this double spending or what the cost of not having this double spending protection is. in terms of like a single token can then be turned into n different tokens. I don't think we need to like require all applications to be double spending secure.
That's good.
Richard Barnes, your turn.
Hi, this is Richard Barnes. I just wanted to raise the question of whether this part of the work, how critical this part of the work is. It seems like the whole point of this work is that the issuer or the sites using Privacypass are trying to do better than earlier more privacy hostile mechanisms. And so it seems like if you had a malicious issuer, they could just revert back to using the other, the older, more privacy hostile mechanisms. Assuming that no one's going to say, require Privacypass. So I think it would be good to understand kind of what that context is, kind of what we're assuming the various entities' capabilities are, because I kind of suspect that if we're going to be in a situation that many of the practical situations where this could get applied will have that property that, if the issuer were malicious, then they could simply not do this protocol and achieve whatever the objective is.
I think there's some hope,
sorry, go ahead.
I think there's some hope that, like, alone this protocol is fairly privacy tight. It's true that a lot of issuers could just not do this protocol and revert to other less privacy positive means of transferring information. So I know some browsers have been working on reducing the privacy negative abilities of malicious actors.
Yeah, and I just to be clear in terms of kind of deliverables for this work, I think I would be tempted to view it as acceptable to simply clearly describe the privacy properties of the protocol itself and kind of deliver an initial protocol with just a clear description, even if there are some of these questions remain unaddressed in the first version.
I think it's still valuable to, at least talk about what these privacy issues is, even if we can't completely solve them. But I think it's worth attempting to solve at least the ones we can with the protocol itself. And I guess that's somewhat of the split between the core protocol doc and the architecture doc.
Yeah, just conscious of keeping scope achievable here.
Dave Thaler, and I think we'll close the queue here.
Yeah, this is Dave. So I'd asked this question in the Java room, and I haven't gotten an answer that I understand yet, so I'll ask it here. Why is double spend an issue? I understand why your token might want to have some notion of an expiration time, but how does it matter, or why does it matter how many uses it has before it expires?
So for some use cases, it's possible that the issuer knows that this user has been active on this website for 2 weeks and only wants to give them 12 tokens, because a user that has been active for that long, that's how much they trust that user. If you allow double spend, then that means one token can just be sent to 5 million malicious people. So if you have one human, they could do this whole transferring thing of copying their tokens and giving it to all their bots, and then their bots could use up these tokens.
So you only partly answered my question, because you start off saying, well, let's assume that you only want to give out 12 uses. That's the part that I'm questioning. Why is it you'd only want to give out 12 uses, which might take 12 milliseconds, might last for 12 milliseconds, or it might last for 12 months? Why would you not say you can use it for the next 12 minutes, regardless of whether it's 12 attempts, 20 attempts, or one attempt within that 12 minutes?
This partially goes back to the transferability question, and these tokens aren't bound to a specific user. So if there's a malicious user that is able to get one token, you don't want that one token to be used arbitrarily many times across arbitrarily many clients. So the issuer wants to choose some number of tokens that they give out that they're willing to pay the trade-off of they may be passed on to bots or other malicious actors.
Okay, so you're saying it's a workaround for not being able to solve the transferability problem. It's not a great workaround, but it's the best you have, is what I'm gathering.
Partially, yeah. I mean, there's also a user who's been on your website for a long time, you're willing to give them more tokens or maybe more longer lasting tokens. So
yeah, that's what I'm asking yeah. I completely agree with having, how long this stuff is valid for, but my question was, why does the number of uses within that time matter? And you're saying it's the closest thing you have to a mitigation against transferability.
And also, if you want a longer time span for the token to be valid, we don't have a mechanism for changing that expiration date that's not privacy leaking. So giving them more tokens that they can use for longer, I guess, is also a way to transfer that, like having a longer expiration time.
Can I just jump in here as well, Alex Davidson? So also the client may not want to use the same token over and over again because that will leak. It will link all the sessions together that it uses that token in. So it's in their best interest in some cases to be issued a finite number of tokens, and they can use each of those without the server being able to link each one.
Yeah. Well, I understand that, but that can be done by issuing one token per session or something that the client wants. If the client wants to preserve its anonymity, you can always ask for more tokens, one per session, or use it within a session. So I think there are other solutions to that. I think the main answer is what I heard before. So we can go on.
Okay, we're gonna move on here. The next question is from Mariana Rekova.
So it was again a comment about the scope. I think somebody mentioned that maybe it would be good to have the protocol specified and probably postpone these discussions on the different security issues. So I just wanted to mention that there is a protocol. The Privacypass protocol satisfies many of these properties. So I think the purpose of this working group should really kind of go beyond this set of properties that's already achieved by Privacypass and look into what possible extensions would bring up as additional issues.
Yeah, I guess the core point of the working group is to make the privacy protocol a real protocol, given that as part of like the IETF. But I do think it is valuable to maybe scope a little bit beyond that, since otherwise it's limited to taking the existing draft and publishing it. And I think there's a lot of more interesting work in the space, the architecture, that is worth pursuing. But I guess that's a question for the BOF and the working group as a whole. Hopefully the charter discussion will help us nail down exactly what extent we want the working group.
Giorgio Nicolas?
Hello, Giorgio Nicolas. Small question. Is it possible to generate a new token from a current token, or do I have to run the algorithm all over again, protocol all over again when my token expires?
So it's not possible to generate a new token from an existing token. This is somewhat intentional and to prevent like one token from being turned into thousands. It's possible that things built on top of Privacypass, the HTTP API maybe, would allow you to submit a token to then get a new batch of tokens from the issuer. But in general, you'd have to do the whole protocol again if you want more tokens.
All right, thank you.
And Ben Kaduk?
Hi, Ben Kaduk here. I just want to get back to Dave Thaler's point and sort of comment that there seems to be a pretty fundamental opposition between having the unlinkable property and the transferable property. So like one of the goals is that the token use is not linkable to the token issuance event, and it seems kind of inherent or intuitive to me that this sort of implies that your token is going to be transferable and not tied to one single client. And because of that sort of fundamental incompatibility between unlinkability and the ability to transfer the token, I think that's why it is so fundamental that we have to consider the double spend protection, even if it's not a fully robust double spend protection, but some level of multiple spend protection.
Thank you, Ben. We've cleared the queue, so we can move on to the next segment. Joe?
Okay, I think before we go into charter, I'd like to make sure that people have a chance to let us know if they're still, kind of unclear about the problem and use cases that have been presented here. So if you still have, big questions about that, now would be the time to ask those. All right, so it seems like folks are fairly comfortable with their understanding of the problem and use cases.
Ben Kaduk?
Ben, did you? Yeah.
I mean, this is Ben Kaduk again. I just wanted to note that the Jabber room is still pretty active with people who maybe are not super in agreement on the use cases yet. And if I'm reading the Jabber room correctly, I would encourage a few people to get in the queue here.
For the next hour or two, supposed to start in about an hour.
Okay, Martin Thompson.
And I will call you.
Helen Jennings, can you mute, please? Oh, he's not listening anyway. Oh, good. Thank you. One of the things that I've not gotten from the discussion thus far, and I think it's part of the problem that people in the chat are having as well, is the relationship between the different actors in this situation and how much trust each one is required to confer on the others with respect to what their motives are and incentives and that sort of thing. So as a client, how much do I rely on the fact that the issuer is not playing hooky? So we have in Steve's thing, the transparency thing that sort of covered off the question of issuers having multiple keys. But we also have the potential, if the issuer and the party that redeems the token in the end being different parties, the redeeming party could have multiple issuers and use the selection of issuer to also segregate clients. And so I'd like a little bit more clarity about what the goals are with respect to that.
I think part of this is the client's going to need to have some policy in allowing only like a website or a party that is requesting a token to be issued to like pre-commit to what issuer they want to use. Like I don't think we can support a case where like you choose an issuer after you know the user's identity, because otherwise I have 50 different issuers for like 50 different users. And part of the idea of having like a registry of the issuers that are registered is that you don't have the ability to spin up a brand new issuer as a client attempts to get a token. So the client, for the most part, has to trust that the list of issuers is reasonable, but otherwise doesn't need to trust that a particular issuer is presenting different like identities to them. I guess similarly.
Right. And so that question is central to all of this, and I'm comfortable with this proceeding on the grounds that this is a detail that needs to be worked out, but I want to highlight the importance of it. That's all.
Yeah, I think this is definitely one of the big questions that needs to be worked out in the architecture and the protocol specific or the application specific documents.
Okay, Joe, back to you.
I think we have a couple other folks in the queue. I think Roman.
Nope, queue is clear.
Nope. Oh, the queue is clear. Okay. So hopefully we have people have a pretty decent understanding of the underlying problem space. Question now is this problem space that do people feel that this is not something that should be a topic for the IETF? Reasons why we shouldn't do this here. So I think, Nick, are you in the queue?
Yep, Nick Doty.
Yeah, I just wanted to check. This is Nick Doty. In terms of should we work on this? Like, do we have a sense of diversity of interested implementers? As a user, as a privacy advocate, I think there's a lot of value to this. I would be happy to provide reviews. If it's just going to be a couple of the largest companies that are going to implement it, then it might not need as much standardization work.
So maybe Alex and Stephen, you can provide some information on who's.
Yeah, so Alex speaking. So I think so as I mentioned in the presentation before, like we have a number of applications that are currently being used. So and we intend to keep exploring them and introducing new applications as well. But equally, we're also looking for wider participation from the community. As you mentioned, like the current applications are limited to a few organizations and institutions, but like it would obviously be preferable for us as well to introduce more diversity to that process.
Eli, could you please state your full name?
Yeah, so this is Eli Kadori from Intuition Machines. We actually have a service called HCAPTCHA, which is one of the current users of Privacypass as well. We're using it for more or less a standard accessibility use case. And so we're not one of the largest companies on the internet, but I think we are quite interested in privacy, and there are certainly others out there like us. So I would expect there to be more adoption as the standards process continues and people become more aware of the options.
Thank you, Eli. Dave Thaler.
Dave Thaler, trying to comment on the overall question, should the IETF work on this? I interpret that question as should the IETF work on this problem as opposed to this particular solution or whatever. And so on the should it work on this problem? I think the answer is yes. I think it should have a close relationship with rats, but I don't know of a better place to do this work, and I've not heard somebody else bring up a better place to do this work, and I think it's an interesting problem. I'm not yet convinced that I can't tell yet whether the solution is in the right direction or not. I don't have enough information. For example, I think it would be useful for the IETF or the IRTF, I'm not sure, both, to look at the question of can you get non-transferability and anonymity in the same algorithm? If so, that would be a better thing to build the solution on top of. You still need protocol work either way. And so overall, the answer is yes, but that's what I would want to keep in mind. Thanks.
Thank you, Dave. DKG.
Hi there, this is Daniel Kangil, ACLU. I do think the IETF should work on this. The concerns that are in the Jabber room about the centralization impacts, but there is a lot of centralization that is already happening, and I do value to kind of, if we don't have a bunch of folks about how it works, and a bunch of
DKG, I'm having trouble hearing you. It seems like there might be an audio issue. So to make sure that we get all of your comments, I'd encourage you to put them in text too.
I'll put them in the Jabber room, but I do think the IETF should work on this.
Tommy Pauly, you're up.
Hi, this is Tommy Pauly from Apple. I just want to say that we are also very interested in this general problem space, and I think that this is something that the IETF should work on. Similar to the other comments, the specific problem solution space that's been explored, I think is a good starting point, but not necessarily where things need to land. But the conversation that we're having here, I think, is the right conversation to start from, and I'd like to see this go forward.
Thank you, Tommy. Watson Ladd.
Watson, I'm from Cloudflare. In fact, I'm a coworker of Alex's. I think this is something the IETF should work on. I'd just like to clarify that this is solving a very different problem than rats. It's or UProve is the other system that came out of Microsoft Research that one would look at. This is really about anonymity. The goal here is to be able to issue a token and redeem it later without being able to link those two transactions. And the token is not really carrying any information beyond its existence, like a coin. It doesn't matter which penny you gave me. You gave me a penny, you get admission. So I don't think it makes sense to put in rats, which is really focused, which is not really concerned yet with anonymity and wants to express a much richer attribute space. It's a very different problem.
Thank you, Watson. Wendy Seltzer.
seltzer W3C, as evidenced by the Q plus rather than plus Q convention. And I also think this is a good area for IETF to work. And from the W3C side, we've both seen some interest and are happy to coordinate on the interactions with web APIs.
Subodh?
Subodh Iyengar, yeah, I think that IETF should work on this. We showed our interest in this by kind of having some private implementations of these. So like it's closed source at the moment, but we also have some implementations of these as well. I'm excited to see an ecosystem evolving around this as a result of like the IETF process and standardizing it and satisfying more and more use cases as we go through this process. That's why I think that the IETF should predominantly work on this, so that it's not like only fits the requirements of a few big companies as well.
Thank you. Andy Nadelin? Nadelin?
Yes, Tony Nadelin. I believe this is something that the IETF should work on. I do have a concern over the signed redemption records that come back possibly being used as a form of authentication, you know, if these records wind up getting cached and things like that. So I do think there has to be a little bit more security considerations thought into this protocol.
Thank you. Last call for responses to this slide. Joe, back to you.
Okay, so I think, you know, it seems there's general feeling consensus is that the IETF should work on this. I'd like to try to see if we can get a feeling for who would be interested in contributing an effort, either as a reviewer or contributing text or implementing, just to get an idea. What we did seen in some of the previous BOFs is to use the chat window to put a +1 if you were willing to contribute some effort towards this problem, either reviewing or contributing. Okay, so there's a fair amount of interest. It's not completely clear how much of it is willing to review versus author or write text. That might be a all right. I think what kind of the next steps would be to go through charter and make sure that we have an understanding of the scope, because I think that's the next sort of thing we would need to do is get to a point where we have some agreement on how we would move forward. So Alex, I think we can present about charter.
Sure. Cool. Ready to go? Yeah, so thank you for all your questions and comments. It's been really helpful. I'm just going to present a few slides that will introduce some of the key points in the charter, and then I think we're going to move to GitHub and we'll go through it line by line from there. But yeah, so let's go to the next slide, please. Cool. Hyperlink.
Got ahead of myself, sorry.
Yeah, so the charter that we currently have lives on GitHub. I've also posted it to the mailing list, so you can read it there if you prefer. This version of the charter was previously discussed and written mostly at a side meeting that took place in January, we're in accordance with a number of individuals. And yeah, so next. Cool. So the main goals of the charter, as I mentioned before, is to develop a protocol in the internet for the internet and web context, along with the APIs and surrounding architecture for redeeming a set of unforgeable tokens, and these tokens should attest to the validity or ownership of some attribute being held by a client. And as a second key property, the tokens are cryptographically unlinkable to preserve the client's privacy. And just on this point, we've had some good feedback about how this interacts with transferability and whether these two concepts are possible to align. And this might be something as well to consider in the chart as well, maybe just as a discussion point in the documents. So next slide, please. So the scope of the working group, as we'll see, is the 3 core documents that Stephen laid out. So we have the protocol document, which essentially describes the one-to-one message exchange between a client and a server, and the API that's required and the implementation of that API based on the cryptographic implementation that we use. There's the architecture document, which lays out the wider ecosystem that we could construct around that protocol, with the clients and servers that interact together in that ecosystem, and how key management works, and the analysis of the security and privacy concerns around that. And then the HTTP integration, which Stephen touched upon, may be something that we coordinate with W3C further down the line. I think currently we're thinking that we'll write these documents to get a version of them and then coordinate with W3C after, but maybe it would be good to liaise from an earlier point. And then the other commitments in terms of the scope are to obviously provide a detailed and concrete analysis of the security and privacy impact from using this protocol, so that we can properly calculate the privacy budget allowed to each client, as this is the main concern of the protocol, and then a commitment to develop interoperable implementations which can then be used to instantiate this ecosystem. And as someone brought up in the previous round of questions, like the scope of this working group is focused on the web context, but these implementations may well be something that you could use outside of that, but that's not in scope of the working group. So next slide, please. So before we jump into the charter, some of the open questions that I just want to raise. So the milestones for the group are essentially going to be these 3 core documents. We currently don't have any exact timeframes for those, but maybe this is something that we'd want to agree either now or on the mailing list afterwards. And in terms of those milestones, there may also be extensions that we might want to coordinate, and deciding a policy on accepting those extensions might be something that we want in the charter, in terms of how the working group would review and edit and accept those extensions. And obviously, if there's any other feedback, that would be really useful for us. So I think I'm at the end of my slides, so if there's any questions before I want to jump in, please do ask them.
Yep, Ben Kaduk, you're up.
Hi, this is Ben Kaduk. If you could go back one slide. So I have 2 questions, and I think we can answer them separately. So the first question was relating to sort of the milestones, and I think on the last slide you had mentioned that you were seeing these existing 3 documents as being sort of key milestones for the group.
Mm-hmm.
But I wanted to sort of ask how strongly we really are tied to that breakdown, as opposed to potential other ways to divvy up the work in the space, and also to ask whether the security and privacy analysis would be bundled into those 3 documents, or a separate milestone obviously would be a deliverable of the group regardless. So how strongly tied are you to those three existing documents as the milestones?
Good question. So I think essentially those core documents were decided in the previous meeting, but so that's what we've currently gone for. But in terms of what we're actually tied down to, like these milestones are malleable in a sense. If people think that some of this work could be incorporated into condensed into fewer documents or made out into more documents, then that's something we can definitely discuss, and maybe that would be the best thing to go forward. And then in terms of the security and privacy concerns, these are things. So I've highlighted them here as I believe they're very important to the instantiation of the ecosystem, but they're things that are covered in the architecture document specifically.
Very good. And then for my second question, I think, can we go back one further slide? We were talking about how the issuer is sort of providing the validity of some attribute being held by a client. And I was sort of wondering if we see it as pretty fundamental that any single token gives indication of one single attribute, and this has a corollary that any single issuer only issues tokens about that single attribute. I know we've talked about sort of the is a human attribute a lot for the capture-like use cases, and there was a little bit about the Brave browsers. I think it was the BATS token that is sort of one unit of currency in some sense. Do we think it's pretty fundamental to have the single attribute, single issuer per token relationship?
So this is maybe something that Stephen may also want to comment on, but I think personally it's a one-to-one relationship between the issuer's key and the attribute that's being considered, in the sense that any one issuer should only be checking for that attribute, and that key and the key they use essentially corresponds to whether that attribute is owned or not.
Yeah, that's how I was picturing it in my head, but I wanted to make sure we were all on the same page.
Okay, Martin Thompson.
Thompson, we are not all on the same page, I suspect. I understand that this is a property of the system as described to us, the one that we have an existence proof for. But I don't think this is a necessary property of a system of this shape necessarily. And so I'm aware of techniques such as those in DigiCash where clients and issuers can agree on information that is that carries across with tokens, and that potentially offers a different way out for some of these problems. When we get into saying that clients and servers and issuers have to have a single purpose, then we introduce some interesting privacy implications, in the sense that now if any party involved can decide on what property they want to carry across and what combination of properties they want to carry across, then you lose control or could lose control over the information that's transferred across. I think I'm a little uncomfortable with that. I would like to see a little more discussion about the relationship between the different entities involved before we get into concretely putting those things down in the charter. I see that the charter that's up online doesn't explicitly list those documents. So I would like to talk through that stuff first, and I'm more or less okay with the charter, but I'm not sure about some of the specific details here.
Sorry, MT, just to jump in real quick, this has been Kaduk as AD. When you said that you wanted to see further discussion about sort of the relationship between the entities, would you be proposing that we specifically charter just to do that discussion and plan to recharter before taking on the specific protocol or API bindings work?
Probably more along the lines of specifically set out to address those questions first before talking about adoption of any documents. Okay, the presentation here suggested that those documents were essentially it, whereas I think we have a little more flexibility in terms of where the group ends up.
Sure, so you're seeing like an initial milestone that is to perform this investigation, and then we can still have other milestones. Great.
or add those milestones as it comes along. Yep.
Yes.
Andrew Campling?
Sorry, can I just jump? I agree with Mine's point. I think that is something that we can do in the charter. We can modify the milestones to do that, and I think that could be a good idea.
Hi, thank you. Looking at the next slide, I think it was. So your slide 4. Yes, that's it. Will the analysis of security and privacy concerns, will that include consideration of the potential for centralization?
So just to clarify, centralization in the sense that all the issuers coalesce around a single entity.
Yes, or very small number of entities, yes.
That is not something that we currently consider. I think I appreciate the point. I think that is something that could be a problem going forward. I think one of the things, one of the open questions that we have is kind of how this ecosystem is developed, and maybe the way we construct it currently is not how it would continue. But I think partially that would depend on what interest we see, but equally, I think I agree the centralization is an issue, and if it turns out that it looks like we will only have a smaller number of issuers and they will come from all essentially the same few entities, then I think that is something we should analyze.
Yeah, I agree. It should. Thank you.
Okay. We've finished the queue. So Joe, back to you.
Okay, so we have, there's been, I see some discussion of charter in the Jabber, but I guess it would be good to kind of go through some of the specific texts and places where people have questions or think the charter should be improved. Let's see, so we have, I think I see Dave Thaler in the queue.
Yeah, so this is Dave. I have a couple of points. I may only cover some of them right now and wait until you get down to other parts. But since you opened it up here, just to repeat some of the previous ones, like I think part of the question is whether the charter should constrain the work to talk about the case where the information is about human test versus some other attribute. Currently, the first line implies the answer is yes. If that is the intent, then that sentence is good. If you want to widen it, that sentence is bad. The second half of that is whether it should be constrained to just a web context or not. And the only place that constrains it to a web context right now is down just a little bit when it talks about the API or whatever. I think, and I did a search. Yeah, right there, right below the cursor where it says responses for web-based applications. And so right now the document for one in HTTP is web-based, but the rest of the work is not web-based. And so I don't know whether that's the intent here. So right now it looks like the entire intent is to scope it to human, but only that one particular item is meant to scope it to a web. And I don't know if that was what was desired.
Alex or Stephen?
Alex speaking. So I think this is essentially just an issue of the text, but I think I agree with your point about human. I think we could probably extend beyond human to client. There was a reason that we chose the word human initially that I can't remember, so maybe if someone wants to jump in and remind me of that. But I think the crucial thing here is that we're scoping to the web context.
Okay, then so there you're saying the entire thing should be scoped to a web context, not just point number 3, and so that's not clear in the existing text at all. So in other words, like the very first paragraph or something like that may need to be updated to talk about it, to scope it specifically down to the web context. I agree with the notion of, hey, let's scope stuff as narrowly as makes sense to fit the current demands and things. And so saying that this one is scoped to the web is okay with me. Once you broaden that past human, then the questions about relationship to RATS comes up. And so under the first sub-bullet of point 1, where it talks about specify the full cryptographic authorization exchange and terminology. Since you're talking about terminology and often the term attestation came up, then there's going to be terminology relationship issues even if the protocol doesn't overlap. And so I think at least the terminology work needs to specifically say it will coordinate or align or be consistent or get review with RATS or something like that, depending on what we think.
Thank you, Dave. Christian, please state your full name.
Christian Wittema. Yeah, I very much like this work, this kind of work, and say I was supporting the charter. But I would really like to see a point in section 2 about the architecture, about centralization risk and how to prevent it. Because, I mean, I am really concerned that this has the potential, if we don't tackle the problem from the beginning, to end up with very few issuers. And so that's something that's to be part of the architecture, that we want to have an ecosystem of issuers, not just one or two.
Hi, Alex speaking. Sorry, I didn't catch the last bit of your point there.
He said that the consideration is that there might be only 1 or 2 issuers if we're not careful and don't note this in the charter.
Okay. Yeah, I think this is something that multiple people now have said, and I think that the concerns are valid, and I can see that being added as a specific point to point 2, and I think that would be valuable.
Becker?
3 points. There was some discussion about this in Jabber, but I think there needs to be some material in here about like how the I thought I said my name, Ben, but I'll say it again. Anyway, there I need to be some text in here about the ability of the client to verify that the size, something at the size the enemy says they're in, right? There's been a lot of discussion about, what happens if you use a separate key for each, for each token you issue, right? I'm not saying we have to have that problem solved now, but I think that, I don't see how this can work unless the client has a way of verifying that that is not basically being cheated by the server, which is presently, does not really presently be the case. Again, the problems you solve, that's why I have a working group. The second point, as MT sort of pointed out, this seems very oriented towards turning this one bit of information authenticated. That's certainly a valid use case, but it seems that there are use cases where you might want to carry more information, and it would be nice to have a charter which contemplated that in some way, or at least even a lot of scope. The third point is this the penultimate paragraph says we hope to have a number of interoperable implementations of clear analysis, security and privacy considerations. I really think that a clear analysis of security and privacy considerations, along with formal proof, really ought to be a requirement for doing any work in this space. Not a nice to have.
Hi, Alex speaking. Thank you, Eric. So on your first point, I agree that should be in the charter. I think that maybe is something that we've missed out. So currently we do have the functionality for the client to be able to verify they are part of a certain anonymity set, because they can verify in zero knowledge that the server has used the key it's already committed to. So that is something that we should include in there if it's not already specified. On your second point, I didn't actually catch it, but on your third point, I agree. I think that needs to be reworded as a requirement. So we have a formal game-based cryptographic proof of the primitives. We might want to go a little further down the line, but yeah, that should be worded as a requirement in the charter. So thank you for raising it. But yeah, your second point I didn't.
Yeah. Oh, my second point was that this of information, namely this is authenticated, and then there's a discussion of like a bunch of clunky mechanisms for having like more than one bit by like, having multiple keys. But as MT pointed out, there are techniques which are known for carrying substantially more bits in the same kind of anonymous token. Maybe we don't need to have those in V1, but it sure be nice not to have them ruled out by the design.
Hey, Ecker, could I toss in a clarifying question here? It seems like as some of the use cases presented described, you can, with the single bit can signal a bigger bucket of attributes that you have done 5 things, and as a result of those 5 things, you get this token. It can signal having done those 5 things later. Is that sort of in the scope of what you're talking about? Or are you envisioning more complex mechanisms?
Well, right. Obviously, it's binary coding, so you can do anything you want. But, you might imagine having a token that was like, so imagine, this case is like I have done a CAPTCHA, right? Basically, the people have in their heads as the use case. But you might imagine, this is a user which spent between 1 and 10 hours on the site, or 10 and 20, and 20 and 40, right? And having to carry each of those individual bit is kind of goofy. And so often you want to have a situation where you can arbitrary data which the user is aware of and the user signs off on, but that's carrying the token. I think Martin alluded to DigiCache as an example of a system which kind of had these properties. So I guess I'm just saying that it'd be nice not to design a system that was like restricted to only carrying 1 bit. Yeah, claims, as we said, claims. Yes, thank you.
DKG.
I don't know if it works. The more bits you have the protocol clarity, or your anonymity. So
DKG, we're still having pretty serious audio problems from you. I would suggest that you use the mic. I'm sorry. Subodh?
Subodh Iyengar. I think the bits question, one of the use cases I've seen previously in the past for additional bits of information is more like binding public information to these tokens as well. So classically, one of the use cases that is not enabled by this protocol is to bind some public information. So for example, like in an ad, one of the use cases that we had was like in an ad ecosystem, you want to be able to bind the campaign to an anonymous token so that like you can, that's additional confidence that this token was issued for this particular ad campaign. If you specify as is, you could make it work with like multiple keys per campaign attribution, but it makes the ecosystem problems more complicated. So I guess the question is more about like, I think while it is possible to make single bit per thing work, maybe we could consider extensions to the protocol as well, but I think that shouldn't block the fundamental work around this, which is like enabling that transference of 1 bit of information, or like 1 bit might represent a bunch of attributes there.
Okay, I think DKG in Jabber says more bits means carved up anonymity sets.
So Alex speaking. So just to jump in, I think the thing with the additional bits is, as DKG says, it does carve up the anonymity set. So we'd have to be careful about what we'd want to do if we want to add extra metadata to the tokens. I mean, it's conceivable that there's room in there for extra bits without completely de-anonymizing everyone, but we'd have to. I think this is something we'd have to discuss in the drafts and come up with some concrete parameterization for analyzing the privacy of the clients in these.
To clarify, sorry, to just Subodh Iyengar here. To clarify, what I meant was more about if the clients might have the ability to choose these public bits as well. So, which might not carve out the anonymity set, but again, I don't think it should be a blocker.
Mark McFadden.
Thanks. One of my concerns here is is this potential for a very narrow band of issuers, right? Basically, it's sort of almost prompting consolidation. And what I don't see in the charter is a mechanism to prevent that. In fact, when I think about the three documents, it doesn't seem to me like it could be a feature of the protocol document. And it's certainly not a feature of the API document. So I'm really puzzled by how the mechanics by which we prevent that from happening, because otherwise we're simply playing into the hands of consolidation, which is something that the IAB has talked to us now for years about. And so I'm sort of confused, and I'd like to hear how it is that sort of having a very, very limited number of issuers would be something that we could find a way to prevent.
So Alex Davidson speaking. So Mark, thanks. I think currently, so this is one of the open questions that Stephen raised, but essentially what we do in the wider architecture document currently is we specify an append-only log which holds the public commitment information which is necessary for issuers to be able to produce tokens. And I think, I guess your comment comes into the centralization aspect, which has been brought up before, but essentially I think what would have to happen is there would have to be some sort of public audit mechanism for auditing this commitment registry and making sure that the clients are happy with what's going on at any one time. And I think, but again, this is definitely something that's intended for the architecture document, but is not necessarily, we don't necessarily have a great answer for right now. And it's one of the to-dos, the official to-dos that we currently have. So I think it's a very important point, and it's something that we will have to solve in order to achieve this milestone. Does that sort of answer your question?
Yeah, I mean, that's helpful. I think that auditing mechanism is something that is very difficult for me to imagine because I can't think of a parallel that we have to a model to work from. So I agree with you. I think that is a really thorny open problem. And it makes me worried about the whole enterprise, to be honest. Thanks.
Mariana Rekova.
Mariana Rekova, Google. I wanted to make a comment about this additional bits. I think whether they're public defined by the client or by the issuer, I think in both cases there is kind of partitioning of the anonymity sets. And I think both of these extensions are valid and interesting extensions for this protocol. And as Stephen mentioned, once these extensions are proposed, they need to be analyzed as well in terms of their privacy guarantees. But I think in either case, you are cutting down the anonymity sets. And the question is like, how do this like map also to the setting where you have multiple keys being used by the issuer?
Hi, Alex speaking. Yeah, I agree. I think this is something that we should discuss in the document because I think it's clear that there are going to be use cases that kind of want this functionality, and we're going to. And I think so. It is something we should consider in the core deliverables. I think it'll probably span both the protocol and the architecture documents, depending on whether it requires changes to functionality. But yeah, I agree. I think it's something we should do, and I think it's probably closely related to the number of issuers that we have, and also the number of rotations that they do. But again, it's something we can consider.
Dan York as scribe.
Dan York, employed by the Internet Society, but not speaking here, and in fact, not speaking for me, but for Daniel Kahn-Gilmore. Consolidation is a problem, and a serious one. This draft is talking about a mechanism that allows us to place some limits on consolidated information brokers.
Alex speaking. So I agree. I think so. It's clear that consolidation here is something that's missing from the charter, and it's something that we will have to consider at length in the architecture. And again, this comes into sort of like auditing this centralized repository of issuers which are deemed to be trusted by the clients, and we will need a good solution for that.
Martin Thompson?
Yeah, Martin Thompson, one of the questions that's come up in the Java chat that I thought worth relaying into audio was the question of what the nature of the information is that we're passing across here, and what clients understand that information to be. So we've talked a lot about the is a human case, but there's potentially a lot of other things that could be carried in this way. And it is very important, I think, for the client to have a good understanding of what information is being carried here. And also then that comes to the question of how in a lot of cases, users will make the decision to authorize that transfer. Stephen Farrell points out that, so is the browser going to make this decision for users? And when you talk about things beyond the is a human, which is something that maybe a browser might assume someone using a browser is willing to advertise, it gets a little tricky. And knowing what that information is so that you can make a decision about whether to propagate it is something that I think becomes very difficult to reason about. Now, whether the protocol needs to transfer that information or not is something that we should debate.
Alex Davidson speaking. So thank you for that point. I think that is an interesting point to bring up. I think so. The third document, the HTTP document, is essentially with the aim of laying out an API that would be natively available in browsers. And I think you raise an interesting point about whether the browser or the human or whatever is making the decision on who to trust. I think, yeah, that's not necessarily something I've considered, but I could see the value in doing that. And I think maybe what we're going forward from a practical perspective is maybe the browser would offer the human the chance to unsubscribe from certain issuers if they didn't feel like it, if they felt like that.
I don't think asking for forgiveness is really the right approach to take in this case. I think it's just a question that we need to think about a lot more. It's not only who is issuing, but it is what for, and the scope of the information that's being transferred. And I just see Wendy's pointed out P3P again. We talked about P3P once already this week, and I would not like to be talking about that again.
Yeah, I think that point, I think, is something we can definitely we should definitely incorporate into at least the discussion in the document, and maybe even further into the charter.
Okay. We have 20 minutes remaining in the time, but we have cleared the queue. Back to Joe for the last steps.
Yeah, so it seems like we've had a decent discussion on the charter, and there's definitely work to be done. I encourage people to join the Privacypass list so we can work on that in between, after this meeting is done. I guess question for Ben and Roman. Are there things that you would like to see from this meeting that would help you, questions that we haven't asked, or information that you feel would be necessary?
So I don't think that there's a whole lot more I would like to get out of this meeting specifically. I think we've already gotten quite a bit of value. We have a large body of interest in this topic, and we've sort of agreed upon several areas or topics that we want to get further discussion on and further text into the charter. So my expectation of the next steps would be to have probably the proponents put together like a first rough cut of how to integrate the feedback we got today into the charter, and then we can continue the discussion on the mailing list as to whether those proposed charter edits are addressing all of the topics that we brought up.
Sounds good. All right. Did Dave just add himself to the queue?
Yes. One last question when talking about the scoping is because a lot of the discussion has been around the notion of transferability or the lack thereof, or non-transferability or the lack thereof. And so the question is really, should the charter scope this discussion to say, to assuming that transferability cannot be prevented? Should it say that such work should be investigated by this working group, or should it say nothing and just leave that to the discussion of the architecture that's done by the working group? I see two people jump in with answers, maybe. We'll see.
Yeah. So if Alex or Stephen had a comment there, they can jump in. Otherwise, we'll keep going.
So Alex, can you just repeat the point that I missed?
So, for example, the current proposed protocol is designed in a way that assumes that transferability cannot be prevented. Okay, and so the question is, should the charter scope the working group to work on cases that are designed for cases where transferability cannot be prevented, or B, should it say that the working group will also discuss any other ways to deal with preventing transferability, or should it say nothing and leave that discussion to the actual work inside of, say, the architecture document?
So my personal feeling is maybe that I think transferability is definitely something that we have to discuss. I don't necessarily think it belongs in the charter, but maybe what we could say is something like the tokens must be unlinkable with some provisos based on additional metadata. I mean, it depends on the sort of mechanisms that, if there are future mechanisms investigated and discussed that may make transferability not possible and something we want to add, then I think that would be valuable. But I think it might belong more in the documentation rather than as a chartered goal.
Okay, Roman?
Yeah, I just wanted to follow up. I think people might have different feelings depending on how exactly something like that would get dropped in the charter. I think it's worth talking about how that's going to be an assumption in subsequent documents.
So to be clear, are you proposing that this should go in the charter?
Yeah, I'm proposing that we need to put something in the charter about it and not wait for decision time later in documents, because I think it's going to be a cross-cutting assumption across all of the documents. Okay. I don't know what the right answer is, and we need to kind of talk about it, but I think we're going to need to document the conclusion of that discussion in the charter.
So do you think we need to conclude that discussion before chartering? Or can we pose the question in the charter as work for the group?
That's a good question. I think we should. I mean, it honestly comes down to what the group is going to be comfortable with that level of ambiguity. I think we minimally need to pose it in the charter.
Thank you. So the next commenter is either Stussy or Adam W. Could you please state your name?
Yeah, so this is Stu Card here, sitting with Adam Whitaker. So the issue of non-transferability relates to the nature of the authorization. One of the slides said that the first goal was for the token to show that the client holds a certain attribute. And I want to draw a distinction between two subtly different things. The client having an attribute and the token attesting to that fact is completely different from the client having a right that the issuer granted him because at some time he proved that he held some attribute. If the token represents the right granted by the issuer because the client proved that at some point in time he had this attribute, then it doesn't need to be non-transferable. Transferability is no problem. But if the token supposedly represents that the holder of the token actually still now is the same guy that at some point in the past held that attribute, then by God, it had better be non-transferable. So I don't care which way that's handled in the charter, or whether you draw that subtle distinction there, or if you say that non-transferability needs to be in there, but somehow that's got to be addressed.
Thank you. Richard Barnes.
Hey, I was going to touch on this question of transferability. And I actually think Alex was about on the right note to flag this as an issue for study and that we should try and get some precision on. But I don't think I would be comfortable at this stage putting some real hard requirements in the charter around this. It's not immediately clear to me, admittedly, not having studied this real deeply, that the available mechanisms for achieving various non-transferability properties are actually compatible with the privacy goals of this protocol. So I think that this is definitely something that's worth studying and worth characterizing, but I think I would avoid putting hard requirements here.
Thank you. Ecker?
Yeah, Eric Squirrel. Yeah, I concur, Richard. In particular, I'm not entirely sure I know how to define non-transferability. In the face of arbitrary collusion between the person whom the token was issued and the person who's redeeming it, then they might as well be the same person. So it's like actually defining it seems quite not straightforward. So I'm aware of attestation, but that doesn't actually necessarily help. So, so I think we have to put. I'd like to see someone propose a strict definition certainly before we put it in the charter.
Thank you, Ben Kaduk.
This is Ben Kaduk. So whenever I hear the phrase, this is something for more study, I have to ask: is this a matter for the IETF or a matter for the IRTF as a research problem?
Alex Davidson speaking. I think this is something that we can, we have the protocol now, the core protocol that we plan to use. There might be some minor changes to that, but I don't think the API that we're going to use is going to change substantially. So I think this is something that we could study. But again, it'd be good to get some consensus on that.
I think I was focused most on the transferability question that just come up in the previous couple speakers. I agree that the protocol itself is something we can think about.
Right, yeah. But the transferability question is inherent to the protocol design. What I meant to say is that I think the transferability, the ability to transfer tokens is something that I think we can do here as part of this process.
Thanks.
Okay, back to Joe.
Okay. I don't think that we have, I think we've kind of covered what we came here to cover. And now it's a matter of working out the charter details on the list. So yeah, I think Ben's suggestion of proponents going off and reworking the charter based on today's discussion and then having that discussion on the Privacypass list is a good one. So
okay.
Thank you all for coming. This has been a good experience. So.
Before you leave, I want to remind everybody to please, again, put your name in the virtual blue sheet. If you haven't done so already, I'll note that we've had over 160 people in our WebEx today. We do not have 160 names in our blue sheet. So remember that entering your name in the blue sheet is not optional. Thank you.
Thanks. So I guess we're free to go. You get a couple minutes back before the next session.
Goodbye, and thanks for the minutes.